Hi class, put up this video to take you through very quickly questions 1 to 6 for arithmetic sequences, exercise 1.02. Hopefully you went okay with 1.01. 1.02, there's quite a few questions there, but I would encourage you to go through all 30 of them at some stage. So the basic techniques for arithmetic series or arithmetic sequence is a sequence that shares a common difference for each term. So for instance, the expression 2, 5, 8, 11 as an example of an arithmetic sequence, you can see that there's a common difference between each term. We've just, in this case, added 3 to each term. So for a sequence like this, we would get a first term of 2 and a common difference of 3, and we can use those two properties to work out any future term in the series using this formula here for the nth term, which is just substituting the first term and the common difference and whichever term it is that we'd like to get. You can also rearrange this formula, put the d in front of the brackets there. That can be quite useful. The common difference, to work out the common difference, it's just the difference between consecutive terms. So here we've got term 2 minus term 1. So that expression there would give us d. Also, we could do term 3 minus term 2, or similarly any pair of consecutive terms. One thing to look out for, and I'll go through this again in a future video, is if I wanted to know the difference between term 3 and term 1. Now there's a difference of 2 terms here, and that would equate to 2d, which could also be equal to, if I just pick another, the 10th term minus the 8th term. There's 2 differences between 2 consecutive terms. So there'll be 3 times the difference between a difference of 3 terms. That won't come into play for the first 6 questions, but it will be a technique that you'll need towards the end of this exercise. So let's go and apply that. We've got question 1, 5, 9 and y. We need to figure out y. This is pretty straightforward. Because we've been told it's an arithmetic sequence, we can assume that there is a common difference. In this case here, we're adding 4. So if we add 4 to that one, we get y equals 13. In this case here, we're subtracting 6. So if we subtract 6 again, we'd get x equals minus 4. For this particular question, part C, we can use that formula to work out what x is. In this case, x is term 2 of this sequence. So if we substitute those 3 numbers into this expression, we're going to get x minus 45. So that's t2 take away t1 equals t3 minus t2. And if we rearrange this formula, move the x's to the left hand side and the numbers to the right hand side, and if we solve that, we get x equals 72. Using this technique for slightly more complicated questions, so G and H, term 2 is 5k plus 2. I'm just going to put that in brackets, minus 3. So term 2 minus term 1 equals term 3 minus term 2. And I would encourage you, anytime you've got a binomial expression like this one, to put it in brackets, especially for this term here, because it could negate or chain. If this was a minus sign, when we expand that out, that would become positive. So that's sort of crucial. 5k plus 2 minus 3 equals 21 minus 5k minus 2. Tidy up this, or if we move the k's over, we're going to get 10k on this side. If we tidy this up here, we'd get minus 1. 21 minus 2, that would give us 19. And if we add the 1, we would get 20. Probably could have thrown another step in there, but you get the idea. And we'd get k equals 2. We could check if we substituted that 2 back into this bit here. 5 times 2 is 10, plus 2 is 12. And then just check. There's a common difference there of 9. That's a way that you can just check that that value is, in fact, a valid answer. For part H, similar technique here. We'll do term 2, term 1, and term 3. X plus 3 minus x equals term 3 minus term 2. If we we just tidy this up, obviously this first expression won't change, but this one here we're going to get minus x and we're going to get minus 3. And if we tidy that up, 2x minus x would give us x. 5 take away 3 is positive 2. On this side here, the x's will cancel out and we'll just be left with 3. And that'll a nice simple answer of x equals 1. Again, we could go back and substitute 1 in here and just see that it is an arithmetic series. So that would be 1. 1 plus 3 is 4. 2 lots of 1 plus, and you can see there it's an arithmetic sequence with a common difference of 3. For question 2, 3, and 4, I'm just going to do one of these, but using this formula here, we can determine whether it's the 15th value, the 100th value, the 25th value, any particular value we want in a sequence, as long as we have the first term and the common difference. If I was to do this, well, question 2a, for instance, if we want to know the 15th term, the way we write that is you put a little subscript of the term you want, so capital T with that 15th term. The first term in this expression is 4. The common difference, see, is going up by 3. And in minus 1, we're going to put 15 in here for the 15th term. Throw that into your calculator, 4 plus 3 lots of 14, and that would give you 46. Nice quick way of getting any term in a sequence without having to sit there and add 3, which you could sit on your calculator and go 4 plus 3 plus 3 plus 3 plus 3 15 times. Well, in fact 14 times. But this formula is a really quick way of getting those expressions. I'll just quickly do E here because there's some fractions involved. Don't get too intimidated. If you're comfortable changing these fractions to decimals, that can be useful as well. But in this one we have A equals 1 2/5, which is 1.4. That can be advantageous. D here, the difference between these two, you can subtract this from this, or just from observation, you can see that there's a difference of 3/5, which is 0.6. We want to know the 25th term. So term 25 is equal to the first term plus the difference 25 minus 1, and you could just chuck that into your calculator and work out what the answer is. Now, I mean, the question's given to you as fractions. If you get a decimal out of this and write the decimal answer, that's a valid answer. You could change it back to a fraction if you wanted to, but question 5 and 6, just to finish off, we're after the formula for the nth term. So in this case here we have an expression where A is equal to 3, D is equal to positive 2, and so all we need to do is substitute those into that T formula, expand that expression and simplify, and that's our answer. Basically we've got a formula that we could use to substitute any nth value we want, and it would tell us what that value is. So if we wanted to know the 10th term in this expression, we'd just substitute 10 in there and you could see we'd get 21. We'll quickly do 6a here. Same technique. We need the first term and the common difference. In this case here, the common difference is 8. And if we substitute those, expand and simplify, and we get our T formula. Hopefully that has helped you out. I'll come back shortly and do a video for some of the harder questions from 7 through to 15. Good luck.